All right, this is a lecture on the probability using the addition rule for probability for um, different events. If you have this here, you're looking for the probability of an event A or an event B happening. This is a union symbol, and it means that if the union of both the sets together. So you're putting all the possibilities out of A and all the possibilities out of B. So the probability of that happening is this addition principle here. If you take the probability of A and add it to the probability of B, and then subtract off their intersection, that's what this means here, and that's the and, then you're going to figure out what that probability is. If you use a Venn diagram, you can see it this way. If you have A and B, if you take the probability of A, then you're using everything in here. And then you take the probability of B, and you're using everything in here. So you've counted this middle part where they intersect twice, so then you subtract off one time of that so that you don't overlap and use too many. So this is the addition principle of probability. Now, if you have mutually exclusive events means I can't spell very well, sorry. Mutually exclusive, there you go. Events. Basically what mutually exclusive events means is there's no intersection. So this would be A and this would be B, so the probability here would be 0, and you just have to add the individual ones. So these are not mutually exclusive up here, but these are mutually exclusive. So let's look at an example. Let's say from our first video we're looking at a standard deck of cards and we're looking at the hearts and the face cards. So if you recall from the first video that we made a Venn diagram that looked something like this. If we want to know the probability of a heart or a face card, so we want to know the probability of something on this Venn diagram happening, then what we need to do is figure out what the probability of the hearts are and the probability of the face cards, and then subtract off one of the sets of heart and face cards so that we don't double count that. So probability of hearts, there are 13 hearts in a deck of 52 cards, and face cards, there are 12 face cards in a deck of 52, and then we have 3 hearts and face cards in your deck of 52. So we add all that together and we get 22 out of 52, which of course we're going to simplify, always simplify. We get 11 over 26. So this is our probability of getting a heart or a face card. So sometimes it helps to draw that Venn diagram so you can see that intersection part to figure out how we get those probabilities. There's one other little definition I want to go over while we're talking, and I want to tell you about the complement of an event. The complement of an event is its opposite, everything else in the sample space. So for example, if I roll a set of dice, this is my sample space, or I roll one die, let's say. This is my sample space. If I have an event and it's the evens, then its complement, which you write with a little prime here, would be the odds. So, one thing you need to remember, the probability of an event plus the probability of its complement always equals 1, because you have to have one or the other. It either happens or it doesn't. So the probability of an event and its complement have to equal 1. So for example, if we had the probability of A was equal to 2/3, then we would know the probability of its complement would have to be 1/3. So addition rule for probability and complements, look back over and we'll have some exercises to do for you.